Here's a set of coordinate axes with about 6 vectors indicating a curve. If these are r of t vectors for equal times t, then our initial r of t vector might be here. After some time interval, we could be here. After another equal time interval, we might be here. After another equal time interval, we might be out here, and so forth. We can see that this point, if these are at equal time intervals, appears to be slowing down between here and here, and then speeding up at some point, maybe slowing down a little, slowing down some more. It goes this far, then it goes this far, then it goes this far, then it goes this far, and this far. We could draw our delta r vectors just to show the displacements between these points. Now, if I sketch a line segment parallel to this vector, that is, from this point, a line segment from the origin on out, then this would be my radial direction when I'm at this point. My delta r function, or my delta r vector, might have a component in the radial direction, might have a component opposite to the radial direction, and a component perpendicular to the radial direction. At this point, then, I say I've got a coordinate system, and let's use a different color here. I'm carrying a couple of, not a coordinate system, here's my coordinate system, but I'm carrying along, imagine that I'm carrying along a unit vector. U sub r in the radial direction, and u sub theta in the direction perpendicular to my radial direction. Now that perpendicular is going to orient the u theta vector with respect to the ur vector, just as the y coordinate, the y-axis of an xy coordinate system is oriented with respect to the x-axis. That is, so that if I turn the x-axis toward the y-axis, my thumb points up. That's why we call that a right-handed coordinate system. So that at this point, I've got my ur and u theta vector. Now, a little later on, I'm going to be out here, and my radial vector is going to be in this direction, so that my ur and u theta vectors, ur always along the direction of the axis, and u theta always perpendicular to that in the right-handed sense. So I'm carrying along a set of unit vectors as I go, and those unit vectors are changing direction in space, but they're never changing magnitude because, of course, they're unit vectors. They both always have magnitude 1. Now we want to see what this model, we want to see what good this model might be in some applications.